This presentation is maybe a little bit different than what we've seen previously with respect to more kind of higher level programmatic. I don't have any code snippets or anything, but we'll talk about some of the things that are going on relative to the consortium in the Americas, and then we'll talk about, or we'll highlight a few of the ongoing projects that are there. Some are maybe a little bit more on the research side, and then some are things that one of example of something we've deployed on the factory floor. All right. Oh, there we go. Now we're back. Okay, so just as a high level, a few bullets of what we're going to cover today. So one is just what does our membership growth look like over the course of 2019? Who are the Americas side members? And so we'll just touch briefly on a couple of those. We had our big event this last year, which was Automate 2019. So maybe some of you are actually able to attend that. It's the largest conference for robotics in North America and every other year. We'll look a little bit about what happened at the North America's annual meeting, which is the sister to this, what happens here. And we'll look at some of the feedback we received as a result of discussions that we had at that meeting. What's happening with our training and relative to our position on ROS-II, how we engage with the community, and then we'll highlight some applications. So, our membership growth this last year is an interesting combination of some end users, some providers of systems, tools, services, products, and then also the ARM Institute, which is a fairly new Institute for Manufacturing Innovation in the U.S. that has been funding some very interesting robotics research initiatives. So that's the collection. And interestingly, I guess Siemens Energy also joined the Americas side, but I know Siemens has also been a longtime member of the ROS-Industrial Consortium in Europe as well. All right, so Automate 2019. Unfortunately, I couldn't get my video to play on this one, so I've replaced it with just a CAD image. But this is our booth at 2019 and a couple of our staff. And our goal here was to have a demonstration that we could say has some connectivity or affiliation with ROS-II capabilities. And so what we did was we developed a kind of an interactive capability where a user could come up and adjust this flexible pipe that's sticking up off the table, and then our robot would, on the fly, well, after we would intelligently reconstruct the part through scanning, would on the fly kind of trace the ring, or trace the pipe with a ring so it wouldn't contact the pipe. So it would show the power of on-the-fly path planning. So in this case, we used the Intel RealSense sensor with the ROS-II connectivity, and then the rest was ROS-I. So we also had this ROS bridge going. So we had a lot of people come by that were ROS-Industrial Americas members to see what is this, how does it work, and what do you think about the move to ROS-II. And it was a meaningful discussion that we had with the member base. We also were excited to see that even though many companies don't necessarily highlight their use of ROS or ROS-Industrial within their systems, as we walked the floor and we talked to people at the expo, we found many instances or examples of people using ROS, and I think it would be great to start collecting those tidbits of information so that we could publish those at some point. So, yeah, maybe we should try to play that again. But so despite this great, wonderful booth that we had in the demo, we felt like we needed something more, right? And so we said, Thilo, we don't have enough people coming by. So, so he started juggling. So pretty impressive, right?
It was ROS-Industrial Frisbees.
Yes, ROS-Industrial Frisbees. Yeah, so, but I had to throw that in there. So we also had, right following Automate 2019, we had our members meeting. And this meeting was well attended. We had about 100 people in the room, and we had some interesting conversations. I don't highlight all of it, and the content is available for the members on the ROS-Industrial.org website. You can see presentations and content. A couple of the things just to highlight is one of them is we had a really interesting panel session on is ROS-II ready for the factory floor? And in the end, while there is some recognition that there's some challenges, we all have to go that direction. I think that's the end conclusion, is that we have to adopt ROS-II. Matt actually is here. I don't know if he's, oh, there he is back there. He was one of our panelists from Intel with their experiences that they've had with ROS-II. Jerry Towler at Southwest Research has been working ROS-II with unmanned ground systems for several years and had some good experiences to share. So if you get a chance, you should check out kind of the feedback from that panel. It's really good. And then on the far left, I just highlight one of our keynotes was Bastion Solutions. So you heard somebody else, maybe I think it was Roger and AWS reference some of the work they're doing. And it was a very interesting talk where you hear industry provide feedback on why they used ROS and what did they use it for and where it worked well and what kinds of things that maybe they wouldn't use it for. And I think that was very insightful to hear an industry or a product, even product developer perspective on that. So that's also a good talk. And then Matt Robinson is our consortium lead and at Southwest Research Institute. He's on the bottom right. But unfortunately, he can't be here. But it turns out that while we were at Automate, it was also a major, like a Star Wars expo. And so all over the whole facility, people were running around with Star Wars apparel. And so the Force was with us, we felt. So. All right, so this is a busy slide, and I'm not keen on lots of words, but I felt like I wanted to just put some of these things in here so you could see them. As this is really a direction-setting feedback from the members, and we have a lot more feedback than this, but these are some of the things that we highlighted that we thought were important or interesting. One of them is on the, we call it soft, I guess, or softer side, is really, it's not very technical, but what we want to do is start putting some practical case studies onto the website or at least into a public space where people can point to or reference things that are meaningful, that are on the factory floor. We also want to see if we can gain permission from those that do have real-world applications to start talking about what the ROI was, why was the investment made, so that they can talk intelligently with their leadership as they look towards, or others look towards implementing ROS on the factory floor. Somebody else highlighted this week too that we have some needs for better defining some of the terms that we use or talk about, particularly for new people coming into ROS and ROS Industrial. It's like, what is ROS versus ROS-I or ROS Industrial or ROS? You know, we have all these terms that we throw around that maybe if we're embedded in the initiative, we understand them, but it would be great for us to start kind of collecting a repository of practical kind of what are definitions and Q&A. So there's a couple of interesting things that we had from feedback. One of the other ones was reducing the learning curve. And I think that's going to be a collective effort. So it's not something the Americas is going to do. I think it's something that we do with Asia Pacific and with Europe, really identifying what are the key things that we can do to get people better educated more quickly. So it's maybe not an easy task, but it's a good goal. On the technical side, we've had this request for how do we build more tools that remove some of the kind of the details of the coding or the programming. So are there different kinds of user interfaces and things that we can do that we know a lot of us do that we can enable less advanced coding kind of people, so maybe more technician level people on the factory floor to do some level of programming, if you will. And then we've had a request to continue to work on, and I think there's been a lot of great work over the years on planners, path planners, but we'd like to continue down that path, and we saw also a great presentation from FZI this week on their Cartesian planner and the force control. We want to see more of those kinds of things come out for availability to industry so we can do more advanced path planning around applications. The other one too is interesting and important for factory floors. How do you recover from faults effectively? And there's also the situation where you find faults at all kinds of different levels, so system level down even into the code level, and things can come to a screeching halt. But we need a graceful way to recover from errors, and I think there's been some progress there too that maybe we can get more adoption around. So this is a slide that's generated around some more recent conversations within the ROS Industrial leadership team across the globe. The idea is how do we better articulate a vision for ROS Industrial? What are we doing? Where are we going? And so this is a task or a project that we're working on this year within the leadership community to better convey that to not only members but just the community at large. So we have some things that we want to do at a high level that are strategic, kind of cross-cutting, if you will. Some examples of some of those things that we've talked about could be things like quality, user experiences, or just different kinds of novel capabilities. But we also recognize that there's going to be things that we're going to do at the regional level that will be projects, if you will, or things that we take on and that we share broadly across the globe. And so that's this lower level focus area thrusts. And so this is a work in progress, but I wanted to share that with you so that you know that it's something that's on our attention, our mind, about articulating that out to the community. All right, so what are some of the initiatives that we've been working on as a result of some of the conversations we've had with the ROS Industrial America's members? So one of them is we've made a decision that what we're going to do is basically do systems in ROS-2 moving forward, unless for some reason, and somebody has to have a really good reason, so the default would be ROS-2, but there have to be some really good reason why we wouldn't. And so we have our first system that will actually be deployed on factory floor that's all ROS-2, should go into, it be fielded this year. I hope we can share something about that at some point as far as the experience and what the use case is. So stay tuned for that. Let's see. So also, we will continue to support ROS and ROS-2. We have a strategy for that, and I'll talk a little bit about that on a different slide as to what our plan is there. Also, launching relevant focused technical projects. So we collect focused technical project ideas from the member base. Different slide will cover what the ones are that are currently on our list. And then we work hard to provide some new capabilities at a greater frequency. I've only listed 4 here, but we probably have a dozen that came out over the course of the last year. Some of you may be familiar with some of these, so Tesseract and TrajOpt and yet another Kinfu is Yak, and then and Reach, a capability where the robot has awareness of what's reachable within its workspace. So we're excited about these tools that are coming out because we see them being used by the community, and we know that that'll only help improve them moving forward. So also, something that we've been having a conversation about even at this meeting, and I think it's important, is we can take on a role of helping benchmark, if you will, some of the things that we know the community needs. So for example, which DDS am I supposed to use? Well, instead of us endorsing one particular one or maybe even casually saying this one's better than that, well, we're not going to go into that position. But what we want to do is put some efforts around what we kind of call benchmarking. So where we can maybe set up a use case and then use that use case to develop data, so useful data that somebody could look at and say, okay, I see this is useful here in this example, but not this one, or vice versa. Same thing or similar thing with perception sensors. There's many of them out there, so which one do I use for which application? So those are some of the initiatives that we have ongoing, or either we're going to launch. So we talked about, okay, goal for future development. So how do we support ROS and ROS-2? So we know we have these environment layers that we want to be able to connect into with future developments. And so we have that as an important thing in mind. And then we know that we have these messages and topics that we use with ROS and middle layers. So one of the things that we're doing now is we write, if you will, capabilities are things that are independent of ROS, so we can do that in C++ for collision detection or motion planners or whatever it might be, and then we'll put wrapper around it so that we can have connectivity to ROS or ROS-II either way. So that's the idea there. If you ask me super technical questions about that, I'll have to connect you in with my staff about what the process is there, but just wanted to highlight that at a high level of what our plan is. Okay, so we do have a broader engagement beyond the membership base on ROS Industrial in the Americas. And so how do we do engagement with the community? There are some things that we do. We support what we call meetups. You know, a good example is the one that's close to home for us, which is in San Antonio, Texas. That group meets regularly, and we help facilitate, along with some other companies in the area, facilitate bringing together like-minded roboticists. Not necessarily have to be doing ROS or ROS Industrial, but somebody in the robotics community where we have good conversations, rich conversations about technical gaps and needs or network, and be able to pick each other's brains for different ideas about how to solve problems. And it's really a useful thing that maybe already occurs readily across the world, but there's certain areas of the country where we know it doesn't, where there are robotics communities that are emerging and growing, and we want to help foster that. So the picture here is, some of y'all may know Sean. The last event we had was at Plus One Robotics. It's a startup company in San Antonio, Texas, where there's a company, Plus One, that's working in the logistics and warehousing and order fulfillment industry, and they did an open house for the last robotics meetup that we did. So we also support events such as World Move It Day and World ROS-I Day. And if you haven't participated in those and you're technical, we'd love to have you engaged in those events. They're really an amazing day where we solve dozens of problems that are recognized and documented in that list. That list really gets whittled away every year when we do this. So we're excited about the growth of that and the continued engagement that we have with the community to help solve problems. All right, so training. Let's talk a little about training and what we're doing. So in the Americas, the ROS Industrial Consortium supports between 2 and 3 training events per year, and these are typically 3-day training sessions and designed around the working professional to come in for 3 days and get kind of an intense introduction to ROS and then introduction to advanced topic. And we also have a number of universities that will send students there. But what we do with training on the consortium side is that initially it's open to consortium members only, and then at some point, if we still have seats, we'll open it up broadly to the community. And so this is one of the examples, the advanced topics, is taking some of these capabilities like the 3D sensor node and YAC node and mesh post processing and ROS-II, and teaching people how ROS-II works and with the bridge. And so we did that first course in October with good feedback, so positive feedback. So we're going to continue to build on that so that we can push forward still with ROS-II. So how does the ROS Industrial Program or initiative in the Americas receive funding? I wanted to talk a little bit about that. Where are we getting money for doing what we do and the initiatives and the projects? Well, on the administrative side, it's our membership dues that provide the administrative capability. But on the technical side, we have a couple of different mechanisms. One is we have these focused technical projects, and we use the same terminology in the EU, just the way the funding works is a little bit different. But those are projects where the members come together and share the cost of supporting a technical project. Then we also have direct funded projects. And those may not be lots of performers from different companies. It might be a single company, but where there's contributions back to the ROS Industrial repository or improvements to ROS. And so that's the example on the right. I guess that's a video, but it's not playing. So on the left, the blending program, many of y'all may have followed blending over the years. So we've had 4 different milestones of that program, and that's available. The results of that are all available for people to use. And then on the right, just as an example of one of the internal research projects that's going on, which is like a teach by demonstration example, that's an internally direct funded single company development initiative that at some point we expect that the results of that will also get released to ROS Industrial. So those are different ways that things get developed. We also have other direct projects from organizations like the Advanced Robotics for Manufacturing Institute and funds that they put forward to different programs. We'll highlight those here in a second. So a little bit of a differentiator on focused technical projects for the Americas. How does that work? So they are collaborative multi-member projects, and we are looking at challenges that even companies that aren't even in the same technical domain can come around. So we'll typically have a surrogate or a use case that's fairly generic, but yet at the end of the project, when we do a demonstration, if you will, or an actual application, it's done in a way that each of those companies can walk away with something useful to apply to their own application in their own company. And they're typically championed by a member. So somebody says, hey, I've got this idea, who wants to join me? And we help facilitate that discussion. And we help facilitate bringing together the different members. And then the benefit, the benefit is that somebody might pay for only a small piece of the project overall, right? So you divide the cost equally among the participating members. The current topics are listed down at the bottom, and I won't go into each of them, but if any of them strike an interest to you, please see me afterwards, and I can certainly send you out some more details or information about what the description is around each of those particular project topics. One of the things that's happened in the US, I mentioned earlier, is the launch of the Advanced Robotics for Manufacturing Institute. And this has been a really a nice thing for advancement of ROS and ROS-I capabilities. And these are the list of projects that the first two have actually been completed, and then the rest of them are launching to where either they leverage open source content, or in some cases, in many cases, they're all submitting back. And so these are examples of direct funded projects that are maybe more similar in nature to what you find within the ROS initiative and how they work. So I think you'll see more than that as projects finish. We hope to be able to highlight the results of those on our blog post as a collaboration with the ARM Institute. Okay, so I want to switch gears, and we're going to talk more about some of the highlights on applications, so projects. And some of them I'll talk about are things that are, well, one of them we'll talk about is deployed to factory floor, and then others are maybe more researchy, but just to show you the range of kinds of applications or projects that we're working on, just to give you a feel for that. So some of you have watched the evolution of scan and plan over the years. So on the far left, we started initially working on this idea of how do we polish or blend out parts, but where we don't want to teach a robot how to do this. We want it to be able to look at the part and then automatically determine an acceptable path plan, process plan for that part, whether it be sanding or grinding or blending or edge following or whatever it might be. And in the center picture, and we saw this video earlier, is the real-world deployment after fourth milestone, where we did it on real hardware at an integrator site and showing that it's ready to be moved towards the factory floor. The picture on the right is not a grinding or sanding application, but is actually a spray application, but has leveraged the base of scan and plan to deploy something on factory floor that's actually operating today. And unfortunately, the video, the codec is not right for this video, so you'll just have to look at the still image on this one. But on the left, it shows some examples of things where we talked about we want to support some interfaces that help, if you will, hide some of the lower level coding that gives people access to some of the tools that you need to do some of the path planning, parameter setting. And so that's what you see happening on the right is a user interface for that, where you can change different parameters that are part of the auto path, and then that translates out to the robot so that it can execute. I talked about, I'm sorry, this is, I don't know why that, let me get rid of this image because it's on the next page, but stand by just one second. So we've talked about A5 before, and you've seen maybe some posts on it. But what we're going to do is I'm just going to talk you through A5 and why it's important, and then where it's going next. So A5 is Advanced Automation for Agile Aerospace Applications, and it's an Air Force Research Lab funded program. And it launched initially as, really it's more about software than anything. So it's about ROS-Industrial and how do we create a framework that we can plug on different applications or processes that are relevant to the aerospace industry. So our initial use case was, or is sanding, and we've accomplished that. And excuse me, and then what we're doing is going next to some different processes. But what are you seeing here? So what we have is a platform, a robot platform that's could be anything, but it's this particular robot on a rail, mobile manipulator. And the idea is that an operator can, if you will, remotely or teleoperate this thing into position or move this robot into position. And then the robot will scan its wide area workspace. And then based on what it sees, we can find eligible surfaces that we want to create a process path plan for. So in this case, it's this one. So you see an operator can then select that area. So we have a box that you see that just got selected. Following that selection, the robot then goes in with a scanner on the end of the arm and does a more detailed surface scan so that we then can create the automatic path plan for that particular process. So that's what you see here, and we can run that in simulation. So that's the underlying kind of the framework of how do we get to the point where we have paths that are meaningful for the process. And then here's an example of that running just in a lab. We have an example I think I showed last year too on aircraft. But this is important kind of meaningful work to extend scan and plan and continue to if you will, harden some of the repositories relative to this. So we have some follow-on funding that we just have been alerted of that helps us improve the code quality and capabilities and, if you will, harden the system as well as move forward into a non-destructive inspection next step on the process. So we're excited about that and interested to see the investment in the hardening of such a solution for real-world application. So more on the researchy side, so we have these range of projects. Another one that we're working on that we're keen on being able to move the needle on, which is a very difficult problem, is this idea of composite layup. So how do you lay up flexible materials in a way that maybe in some cases as we have to crawl before we can walk, before we can run, in some cases maybe it has some human interaction where the robot does some part of the work and then the human does some other parts. So initially our goal is to be able to, at a low level, have the robot decide what intelligent steps and moves and things that it needs to make for the process. But as we continue to build on capabilities, eventually what we want to go to is really more of a workflow planner so that you have all of the steps associated with a composite layup approach involved. So this is an example of a lower technical readiness level, more research level topic, right? And lastly, we have a couple other programs that I want to highlight that are, maybe they're not entirely ROS Industrial, but they have certainly elements of ROS and ROS Industrial embedded inside of them as part of the enabling capability. So the picture on the top is some inkjet printing technology for aerospace applications. And in that case, ROS was a key enabler for the connectivity between all of the different systems that we were using. It was fundamental for us to be able to get the success that we did. And then on the picture on the bottom right is an example where we leverage ROS for certain parts of the system, such as how do we localize this robot relative to an airplane and relative to the facility that's going to work in, and then how do we communicate back to the robot controller. In this case, we used a Kiba controller for the robot on the bottom right, which has some rich connections to ROS, and that's one of the key benefits for that. So the idea here is that we don't necessarily have to go full system level for ROS. We can use ROS where it makes sense in different aspects of a system or a program as an enabling tool. So I wanted to plug just a couple of upcoming events. February training we have in 2020, it's at an industry or a member company, Glidewell. And so we open that up again to the member community initially. And then if there's still spots open, we'll open it broader to just the user community. And then we have our consortium meeting, and we have we accept any ROS Industrial member, whether you're a member of Europe or whether you're a member of Asia Pacific, at that event. So if you're a member of the ROS Industrial Initiative, certainly, and you want to attend, reach out to us and we will facilitate that. And day one is a public day, and then day two we have a members only where we really dive into what the member needs are. That's how we get good feedback on what should our priorities be, what kind of things should we be working on, what should we not be working on. And so those are rich and meaningful conversations that we like to have. I have to close this slide with a shout out to Asia Pacific and Europe as key partners. So collectively we make this all work. And we have to coordinate so that we provide benefit to the community at large, so we're not replicating or duplicating efforts. And I think our leadership team in ROS Industrial does a good job of that. So they have regular calls and discussions, and we can always do more, and we strive to be to provide excellence to the user community as well as to the members. So thank you for Eric and Thilo for what you all do. So that's it. So yeah, thank you.
Thank you. Thank you, Paul. We have time for question while Rick set up for the next presentation. Is there any question?
I'll be around too, so if you have some things you want to just talk on one-on-one,
Otherwise, I have one.
Oh, okay, great. Yes.
So at Automate, you were telling that people were using ROS, but not really showing that they're using ROS.
Yes.
Do you think there is a reason why? So did you add the change to add more reason why they're?
I think in some cases, I'm not sure if the company or even the developers understood a reason why they would want to highlight that, right? So it's another capability or tool that they use to get their job done. And in other cases, maybe people, maybe want to be a little bit more secret about what they're doing and how they're doing it, right? So if they don't want to share that, hey, we just use some ROS tools for this, because then it maybe gives a competitor some insights into what they're doing. So there's probably a variety of reasons, but I think we can help facilitate kind of getting that out there. If we can recognize, oh, that's ROS enabled or ROS industrial enabled, and then we can say, hey, can we highlight that? And I think in most cases people are generally willing to have that conversation, but maybe on their own terms. Right?
Okay, thank you.
All right, thanks.
Thank you, Paul.